Hey guys, so in today's lecture, we are going to see a new topic that is forced vibrations with rotating or and reciprocating unbalance. So in the last lecture, we have seen forced vibration. So we are we are in the chapter of forced vibration. So in the last lecture, we have seen force transmissibility. So that is how force is being transmitted to the ground, and we have also seen one example. So today we are going to understand same forced vibration, but with a rotating or reciprocating unbalance. So unbalance in rotating and reciprocating machine is the main cause of vibration. So let me draw a diagram of a rotary machine and a reciprocating machine. So suppose this is a rotary machine in which having a center O, having mass M, and it is having a rotary unbalanced mass that is at a distance E and having an angle that is omega t with the axis of mass small m. So this is a rotating mass. So and this system is supported with the help of uh, vibratory isolators, that is spring and damper, and then it is connected to the base. So this is a rotary system. We can call it a rotary machine. So here it shows a rotor of mass m having an eccentricity e and rotating at a speed of omega. The complete machine weight is capital M. So the machine is mounted on a spring and damper as here it is shown. Because of the unbalance, a periodic disturbing force exists, resulting in vibration. Now we will depict our reciprocating motion. So for reciprocating, we will use piston cylinder arrangement. So, this is a cylinder in which there is a piston of mass small m and its center axis, and this is an axis. And now this there is a crankshaft here which is connected with the uh, piston with the connecting rod. So this is the this connecting rod, this is piston, this is cylinder. So here also same case, that this machine is connected to the spring and mass spring and damper system that are vibrating isolators. So here also I will just mention here. So similar analogy of this we can use here. So considering a reciprocating engine having reciprocating mass, that is small m, and total engine mass, that is capital M. Total engine mass as uh, capital M, including the reciprocating mass. So if the crank, so here we need to take care that having the capital M has been include the small m. If the crank length is E, so the crank length is E. So and assuming that the reciprocating piston of mass m to be placed at the crank instead of connecting rod. So the small m is sprayed instead of in crank instead of connecting rod, and the reciprocating system becomes equivalent to the rotating system and having an eccentricity E. So what it is saying that if this is placed here, so it will behave as a rotating system. So if we combine these two systems, so thus both systems, that is rotating as well as reciprocating, can be considered equivalent to the mathematical model. So let's combine both the system. So to the equivalent system, which is having reciprocating and rotating both. So let's consider this a rotating mass of small m and the system mass is capital M and eccentricity E moving with speed omega and angle omega t, and it is isolated with the help of spring and damper. So this is a combined system which is rotating as well as reciprocating. Both the cases are here. There is rotation and reciprocating. So let x be the displacement of the machine. Let x be the displacement of the machine. What is the displacement of the machine mass? So what is the weight of the reciprocating mass? So that is m minus m. So this is the total weight of the machine minus the uh, rotating mass. So we are not considering the rotating unbalance here. So this is the reciprocating weight. So if the machine moves by x to center O, so this center O also moves by x. So this also will move by x. So therefore the mass m also moves in upward direction by x. So however this mass m is rotating as well, it moves further up to a new position. So this is rotating as well as reciprocating. Therefore it will move with a distance x plus or minus some distance of the rotation. So uh, so what will be the displacement? So the displacement of the total mass except the rotating mass, that is m minus m, the displacement of this reciprocating mass, if we want to find out of the reciprocating mass and a rotating mass, the displacement will be here x, but here it will be x plus e sine omega t. So this displacement will be x plus e sine omega t of the rotation, and similarly the velocity will be x dot and x double dot here, and here it will be x dot plus e omega cos omega t, e omega cos omega t, and here it will be x double dot minus e omega square sine omega t. The expression we have taken just derivation, nothing else. So to develop the equation of motion from Newton's law of the motion, we will use the Newton's law of the motion, that is m. What is the Newton's law? That each and every force is the total force is equal to zero. That is, each and every force will be equal to zero. So here the spring force and the damping force is acting in on the upward direction to balance these forces. So we will use here kx plus cx dot on the right hand side, and on the upper side there are two forces, that is first is that is m minus m, that is reciprocating force and rotating force. So what are the reciprocating and rotating force? So here, as this force are acting in downward direction, so we'll take this as negative and this upward we are taking as positive. On the left, so this will be, the reciprocating mass will be minus m into x double dot. This is the reciprocating force, that is mx double dot, and rotating force also we need to find. So this is the rotating force. So rotating force, the mass will be minus m into x double dot minus e raised to omega square sine omega t. So as we know that how, what is the formula of force? Formula of force is m into it is mass into acceleration. So for finding the reciprocating force, this acceleration we have taken and mass we have taken, that is total mass minus rotating mass. So rotating mass we have deducted, so we'll get the reciprocating mass. So we, with the help of this, we got the reciprocating force. And similarly, to find the rotating force, we have used the rotating mass and the rotating acceleration, that is this. Because we know that the formula for force is F is equal to ma, and instead of a we can write x double dot here. So that only we have used, nothing else. So I hope you got what I'm doing here and what I'm trying to say. So it's nothing but the summation of all the forces according to Newton's law. So if I bring this minus side on the right, so all the terms will be positive. So it will be m x double dot minus m x double, sorry, plus, sorry, minus, so mx double dot and plus mx double dot and minus m e omega square sine omega t is equal to kx plus cx dot mx double dot mx double dot. So we are left with here mx, sorry, plus kx plus cx double dot cx dot equal to 0. So mx double dot minus m e omega square sine omega t plus kx plus cx dot equal to 0. So this is the equation. And if I bring this term on the right hand side, so I will get mx double dot plus cx dot plus kx is equal to m e omega square sine omega t. Now as you can see that this equation is similar to the forced vibration, force spring mass damper vibration system. And if we compare this, then this constants we are taking as f0, that is m e omega square. So we will get here mx double dot plus cx dot plus kx equal to f0 sine omega t. So this equation is almost similar to the equation of forced vibration. And so we can write directly the answer. What is the answer? So answer here is x, amplitude is f0 by k upon under root 1 minus r square whole square plus 2 zeta r square. And this is the direct answer here. So now this term, that is 1 upon 1 under root 1 minus r square whole square plus 2 zeta r whole square. So this term we can write it as magnification factor, as we know that. So we can write x is equal to f0 by k into m. M is magnification factor. So here after writing the magnification factor, if we just put the value of f0, what is this? Me omega square. So what we'll get here is x equal to me omega square by k into m. So here not to get confused with this m and the total m, if we don't want to get confused, I will just write here m dash as a magnification factor, because we have also used capital M as a total mass here. So this is a different term, so I will just use m dash, so not to get confused with the total mass. So now but we know that under root omega n is equal to under root k by m. We know that. So instead of k, what I can write here is m omega n square instead of k. So I will write here instead of k, so that will be m e omega square m omega n square, and here m dash. So this m and this m are different. This is total mass and this is a magnification factor. So therefore, so x is equal to now omega by omega n. What it is? So omega by omega n is nothing but frequency ratio, that is r. So I can write here is this m by m e r square m dash. So uh, if I want to substitute uh, this terms over on the right hand side, so I'll get m x by m e is equal to m dash r square. So this term mx by me is a dimensionless quantity. As you can see, this is mass, total mass, this is rotating unbalanced mass, this is eccentricity, or this is the radius distance of rotating unbalance, and this is also amplitude. So this the value of this is a dimensionless quantity, and gives us a dimensionless steady state amplitude as a function of the ratio, frequency ratio r, and magnification factor, that is m dash. So let's draw the graph of mx by me with respect to frequency ratio r. So if I draw a graph, on the x-axis there is frequency ratio, and on the y-axis there is mx by me, So here suppose the frequency ratio is 1 here, and here it is 2, and here it is 3, and here the dimensionless quantity is 1, 2, 3, and 4. So the graph will be such that if we take different quantities of zeta, uh, so the graph will be such so as you can see here, so this is for zeta equal to 0, and this is also for zeta equal to 0. This is for zeta equal to 0.25. So when zeta is equal to 0, so what does it mean? That there is no damping coefficient, so there is no damper. So it is only with the vibration is not having any resistance, and is a and it is an undamped system. And here the zeta equal to 0.5, zeta equal to here let me take one more line, zeta equal to 1, zeta equal to 0.7, and zeta equal to 2.0. So as you can see that when frequency ratio is 1, so the amplitudes are the maximum. So what does it mean? So it says that when the force frequency is equal to the natural frequency, that is r equal to 1, means omega is equal to omega n. So at that time resonance occurs. So at resonance the amplitude are always maximum. So this x is getting maximum and infinite. The amplitude is become maximum because m, capital M and small m, they are constant, there are mass, so it will not change. And also the e is also a constant, there is a distance, but the amplitude is only a changing here. So that amplitude is getting to infinite, that is at resonance. So therefore all the amplitudes are maximum. And for different values of zeta, as you can see that when the damper becomes much and much more valuable, means the damping is more and more effective, as you can see the amplitude is reducing very fast. So more the resistance, so damping is nothing but a resistance, so the amplitude will also reduce. So this is the graph of the amplitude versus frequency factor, or you can say frequency ratio, that is omega by omega n. So this is the theory for reciprocating and rotating mass. So I hope you understood this thing, and we will see forced vibration due to base excitation in the next lecture. So thank you very much.